All are present. Hello. Whether all are present and you are listening to me actively. Yes or no? Anurag is saying yes. And you are also saying yes. Aditya is saying yes. How about others? See, for my lecture, okay, it is quite easier for me to identify who is listening and who has just turned on the meeting and doing some other work for us. If you are saying yes, and if you have taken the snapshot, you can try the examples side by side, and let us start something from your side. Okay, so Shubham Mani Kare, Mani Keri. Okay, whether Shubham is present in this meeting? Shubham. So what we have to do? I'm calling a name. You will be turning on your microphone and saying few things about yourself and about your decision to select the computer engineering branch. I know that you are having communication lab subject and you can consider this as a practice along with solving your examples, and moreover I'm having intention to know each and everyone from SE computer. Okay, so for that reason I am calling a name. You have to turn on your mic and say a few things. Okay, so the first turn to Shubham. Over to you, Shubham Manikari. Whether Shubham is present? Yes, whether Shubham is present?
Yes, sir, I am present. There is a network problem,
Okay, go
so
ahead. Go ahead. Go ahead. Shubham, uh, can you give a short introduction about yourself?
yes, I'm Shubham. My name is Shubham Manigri. I am from Kolhapur district.
Okay.
Hello,
Yeah, yeah.
are you?
Yeah, yeah. I'm listening. Good, good.
Just I am now in lockdown. By lockdown, I am. Hello,
Go ahead, go
sir.
ahead, go
Are
ahead.
you hearing?
Yes, yes, yes. I'm hearing. You are audible. Go
Yes.
ahead, Shubham.
Okay. I am in a second year computer engineering.
Okay,
I love to programming, also the playing football and cricket.
okay. Good. Good to know. Okay. The any specific reason behind selecting this computer engineering branch?
I love programming, so
Okay. Uh, So you are having a passion of being a programmer or somewhat software developer also, isn't it?
hello, sir. I can't hear you.
You're not able to hear me. Okay, okay, okay. No problem.
Okay.
No problem. Yeah, good. Now you can turn off your mic. Thank you.
Okay.
Now next one. I'm randomly selecting. Okay, so do not bother that I'm calling anybody specific. Just a random thing. Whatever I am observing. If you are cooperating, this will be a good thing. Okay? Something out of. And I'm not saying that we are only doing this. You have been given these examples. You will be solving these. And in case of doubt, you will be asking. Okay. For those who have not taken the snapshot, can take the snapshot. We have to solve these examples using principle of mathematical induction, which I have discussed in the yesterday's lecture. Good. So after Shubham, okay, Ashish, Ashish, whether Ashish is present? Ashish, are you there? Ashish Kapoor. Yes, sir, I'm on PC. Okay, so can't you talk on PC? Let it be. No problem, no problem. Shreyas, do we have Shreyas on the call? Okay, Ashish, no problem. Do we have Shreyas? Yes. Shreyas, go ahead. I want to know about you. Yes, Shreyas. Do you have any problem with the network? If not, you can turn on your mic and go ahead. My desktop has become course like nothing. Okay, no problem. No problem. No issue. No issue. Okay, who next? Who next? Atharva. Atharva, do you have the same problem? Atharva Joshi? Can you talk a bit? Atharva?
Yes, sir.
Go ahead. I want to know about you.
Sir, sir, I am Athro Manish Joshi.
Hmm.
I am from Baramati
Okay.
and I am a computer student.
Hmm.
I love, sir, programming and become a developer. So I have chosen the computer engineering.
Okay, very nice. How is your experience of learning discrete mathematics with me?
Very good, sir.
Very good. Okay, are you getting the things which are being explained in the lectures or there is some problem?
No, no, sir. All things are very good, sir.
Okay, no issue. Good to get your information. Okay, thank you. You can turn off your mic.
Okay. Thank you, sir.
Next. Okay, who is next? Aditya. Do we have Aditya on call? Aditya Maskar?
Hello.
Aditya, go ahead.
My name is Aditya Vilas Ramaskar.
Yeah.
I am from Islampur, from Sangli district.
Okay. How is the situation there about Corona?
Uh, there are increasing some patients, but I
Okay.
am fine.
Okay. Take care of yourself. Okay, go ahead. Go ahead.
Okay. I choose computer field because when I used to play video games,
Hmm.
uh, I was a little bit interested at that time how it is made.
Okay.
So I
So you
choose
have
computer.
okay. So you have chosen this branch. Is
Yes,
it okay? Okay. And about discrete?
yes, it is amazing experience. I love logical reasoning questions.
Okay. So what is your score of first year?
9.11 pointer.
Okay, very nice. Good, good, good. Only the thing is, okay, the last month attendance is ready, and I have observed that there is some irregularity in your attendance for discrete mathematics lecture. Is it?
There was a problem when I was sending message. It
Mhm.
is not used to send.
Okay, not about message. I'm asking you, you were not present regularly for the lectures during the last month.
No, I was present, but I got disconnected sometimes.
Okay, okay, okay. No issue. Be regular hence onwards. Okay.
Yes, yes.
Yeah, yeah. Thank you. You can turn off your mic. Okay. Good. Next, let us pick someone from girl. Kimaya Kate. Do we have Kimaya Kate on call? I want to know about you. Okay. Please go ahead.
Sir, can you listen me?
Yeah, it's perfectly fine.
I am Kimaya Sudhir Kate and I'm from Baramati itself. Uh, Means I had selected this computer branch because I love doing programming and developing software. So it's my passion to do that.
Okay, so you are following your passion. Okay, good to know.
Yeah.
Okay, and how is your experience of computer engineering department so far?
Teachers are nice, they are explaining well, doing their job perfectly. So it's our duty now to do.
Yeah, so what extra efforts you are putting? Okay, as you are at home, okay, there is plenty of time doing other extracurricular activities. So, do you want to contribute anything with your friends that you are doing extra?
Yes, sir.
So, what extra activities you are doing?
Means I'm trying now that programming which teachers are giving, trying to do something new or some logical based learning.
Okay, good. What was your first year score?
7.27.
Very nice. Good, good, good. And about this subject, this particular subject, how is your experience?
So you are explaining well, and the doubts are getting cleared, and we can connect you personally also. So you are doing well.
Okay, everything is fine. Good, good to know. Okay,
Yes.
thank you.
Okay, thank you, sir.
Next, let us say Neha. Do we have Neha Zamzam on the call?
Yes, sir. Can you hear me?
Yes, I can hear you. Good.
I'm Neha Zamzar. I'm from Baramati.
We are having okay around 50% in the SC computer who are from Baramati, isn't it? All localities. I am too from Baramati. Okay, good. Good.
What else have to say, sir? Sir,
You
I've
have
joined late actually.
okay, so I have given you examples for solving. I think all of you have taken the snapshot of these four examples. You will be solving these examples simultaneously in your notebook. Okay, this is the first activity. If you are having a doubt with respect to any of these four examples, you have to ask me. Moreover, I am getting introduction of each and every one of you in the meantime. Okay, so you have to tell about yourself, then you will be telling me why you have chosen this computer engineering branch. Thereafter, you have to tell something that you are doing additional. Go ahead.
Yes, sir. I've chosen this branch because I used to love computer. Means I was interested in how display works or how if we type something, then how actually things process or how websites or apps are being created. I
Okay.
was just interested in these things.
Okay.
So
So, what extra efforts you are putting for improvising your skills related with programming? Are you doing something
on
else apart from this academics? Okay, for improvising your skills?
no, sir.
No. So you can focus on few websites which you can get through. Okay. Those websites are excellent, likewise Geeks for Geeks or Hacker Rank or anything. If somebody is trying for becoming a good programmer, I would suggest you to check for top coder, Hacker Rank, and Geeks for Geeks. Okay, on Hacker Rank as well as Top Coder. Okay, Top Coder, you will get plenty of coding exercises on a daily basis, which you can go through and improvise your knowledge on any programming language or skill. In the meantime, okay, as this is the scratch starting, I would suggest you to concentrate on C, C++, as their syntax is totally different as that of Python programming. So once you clear with these basics, you can continue with your zeal of programming. Okay. Okay, good to know about you, Neha. Okay, you can turn
Thank
off
you,
your
sir.
mic. Okay, who is else? I'm finding the persons who have not okay discussed anything so far with me. Those I want to know. So let me go through these. If names are familiar, okay, I would hardly ask you to introduce. But if name I'm observing some name which is not familiar, then only. That is not the case. Pranav, do we have Pranav Mahamuni on the call? Pranav Mahamuni, do we have? Yes. So can you turn on your mic, Pranav?
Yes, sir.
Yes. Go ahead. Go ahead.
Sir, I'm Pranav Mahamuni I'm from Satara,
Okay.
and I chose this branch as I was curious about this, that how like we are in the age like we are using technology, but how does this work? So to find out how does this work, I chose
Okay.
this branch.
Very good. What is your first year score?
Then I have a back.
Back. Okay. How many? Would you like to discuss or no? Okay. 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 No issue. No issue. What is your experience? Okay. Would you like to share your experience about this particular subject or overall department?
It is good.
Okay. How
It is
many
a,
lectures you have attended?
sir, I'm consistent. I'm not. I have
Have you
attended
submitted
every
all the
lecture.
assignments?
Yes, sir.
Okay. Okay. So you are regular. You want to say?
Yes, sir.
No issue. Thank you.
Thank you.
Okay. So, my question to all of you, we are having 47 on board. How many of you are comfortable with sharing your screen? You can reply in chat window. If you are able to share the screen on this Google Meet, can you share? How many of you know how to share the screen? You can reply in the chat window. There is an option to share. Okay, in the Google Meet, I am sharing my screen. In the same manner, you can also share your screen. How many of you can share your screen? Abhishek is saying no problem to him. Okay, how about others? It may be mobile phone or it can be your laptop or desktop, whatever. If you are able to. Okay. Yes, yes. Yes. Okay. So those who are saying yes, okay. I will now stop presenting my screen and I will ask you, Ruturaj, can you show the solution of six problem? Okay, this is problem number six. If it is ready with you, if you are able to share the screen, you have to explain the solution of problem number six. Will that be fine, Ruturaj, from your end? Something new I am trying. Okay, nothing else. We are having plenty of things to do, but let's check if we are able to do this thing. Not solved it. Okay. So who has solved? Who is saying yes? Yes, Parkay, have you solved? Yes, have you solved? No. Sejal Shinde, have you solved? So who has solved and who knows to how to share the screen? And is there anybody who has solved as well as want to share the solution on the screen? See how to share. You have to take the snapshot image on your mobile phone and you can show that image as a solution. It is quite simple. So who can show the solution? Anyone? I'm not getting any answer. Abhishek, would you like to show the solution on screen? Abhishek, Prathamesh, Anuraj, anyone? Aditya. Anuraj is saying yes. Okay, so what I will do, Anuraj, okay, do you have microphone facility? Anuraj, we will start from Anuraj. Okay, Anuraj, do you have microphone facility? Can you turn it on? Okay, simultaneously along with sharing the screen. Yes. So the example
Yes,
number
sir.
6. Okay. So example number 6 solution will be given by Anuraj. Okay. I am stopping presenting my screen so that Anuraj will be able to share his screen and he will discuss the solution of problem number 6. Okay. So I am stopping presentation. Anuraj, now I am attending to this meeting. You can start the presentation. Okay. Go ahead.
Yes, sir.
Okay. I will turn off my mic as well so that there will not be any disturbance. Okay.
Sir, my screen is visible.
Yes, it is visible. Go ahead, go ahead. Good. It is visible.
So first step is for P of 1. We have to prove LHS. We have find LHS. It is 1 by 2. Then we find RHS. It is also 1 by 2. Hence, we can proceed further. For step 2, let P of K be true. Then our P of 2, let P of K be true. Then expression is this. And for step 3, for P of K plus 1, RHS is equal to this. And we find LHS. And LHS is also equal to RHS. This is my solution.
Just a second, Manraj. Okay, just zoom it and can you explain how that LHS is equal to RHS? How it comes?
Sir, first put K of K plus 1 in instead of N. Then here, one step back, it is 1 of K plus 1.
Okay.
According to step 2, it is a K upon K plus 1. Then further solving, it is equal to RHS.
You are taking denominator as a common and you are solving
Yes,
it
sir.
further, isn't it? Then
Yes.
you are getting a quadratic equation, you are finding the factors and cancellation, and then you are
Yes.
getting your final RHS as K plus 1 upon K plus 2. Very good. 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 Okay. Just hold on. Don't stop sharing. Okay, hold on.
Yes, sir. Yes.
Is there anyone who has confusion? You can ask Anuraj. Okay, he will guide you if you are having confusion. Whether it is clear? I am asking others. Okay. Do you have confusion? Yes, Viraj, do you have confusion? What is the confusion? No confusion. Okay. It is clear that you are saying. Okay. How about others? Do you have confusion? Others? Anuraj, very good try. Okay, you can turn off your screen sharing. Good.
Thank you, sir.
Okay. Do we have Kunika on the call? Would you like to share example number 7 on the call? Still solving it 7. Okay. Anybody else who has solved example number 7? Abhishek, have you solved example number 7? Solving. Okay. So if all are solving, okay. Prathamesh, have you solved? Not yet, sir. Okay. So who else? Vidil, have you solved? What is it? Not sir, still solving. So is there anyone who has solved and would like to present a solution? Otherwise, I am there to solve all the exams. But I want you to come forward and have such interactions for at least this lecture, something new. Shraddha Bolshitte. Okay. What do you want to contribute? Solving, sir. We are going to cover 6 examples. Okay, 4 you are solving only one. I guess all of you are having headphones. So along with listening to me, you can continue solving on your notebooks. Okay, there should not be any harm solving. So now I will not call any name. You have to come forward on your own. You can simply type in chat window. I am ready to explain. Whosoever. Okay. Viraj, have you got the answer? Not yet, sir. No. So I think one solution for today is enough. I will explain few problems. So first of all, take the snapshot of this entire thing. Have you taken the snapshot of this thing with you? These are the problems that you have to try. Okay. Have you taken the snapshot? I hope you have taken the snapshot. Okay. What I will do, I will explain example number 10, which is little bit tricky. And also, I am aware that you will be able to solve, but let me solve. So it is given that we have to prove that what is your 1 into 1 factorial plus 2 into 2 factorial plus up to n into n factorial is equal to n plus 1 whole factorial minus 1 for all n greater than equal to 1. So this example I am going to solve completely. Okay, so all of you, okay, whether you are able to see my screen, you can stop for a while about solving that particular examples. Okay, you can try them afterwards. Just observe for this particular thing. Okay, so it is. So what is the base value? Base value given is 1. So we are going to start from step number 1, where we are finding out n0, n suffixed with 0. While accessing the examples of homework, last homework, I have seen that you are also writing n0 like this. you should write n suffixed with 0. This 0 is suffix. Okay. So value of n0 is 1 in this case. So for step number 1, basis of induction, I am putting P of 1. What is P of 1? Predicate of 1. I have to look for. So LHS in this case. LHS, I need to replace every occurrence of m by 1. Okay, so it will be 1 into 1 factorial. I was having n into n factorial in the original predicate P of n. I have replaced n by 1, so it is 1 into 1 factorial. This comes out to be 1. What is on the RHS side? On RHS, we are having n plus 1 whole factorial minus 1. Instead of n, I have to put 1. So what it is? 1 plus 1 whole factorial minus 1. This comes out to be 1 plus 1 is 2 factorial. What is the result of 2 factorial? It is 2 minus 1. This comes out to be 1. So I can say LHS equal to RHS. See, while solving the examples of mathematical induction, you all are supposed to follow all these 3 stages. I have seen couple of solutions which were having only step 3. That is invalid. You have to solve for step 1, step 2, and then only step 3. So as we are observing, step 1 is clear, LHS equal to RHS. We will go for step 2. Simply, you are not supposed to write LHS equal to RHS. Okay, after this, what to write? Hence, P of 1 is 2. Okay. Step number 2. Step number 2 is assume P of k is true. That is to assume. That it means what? What is our assumption? That is 1 into 1 factorial plus 2 into 2 factorial plus up to k into k factorial is equal to k plus 1 whole factorial minus 1. This is my assumption. I have replaced every occurrence of n by k. This is our assumption. This is true. That we are assuming. In step number 2. Okay. So what is step number 3? Step number 3, we have to prove for P of k plus 1 is true. That is to prove. That is to prove what? 1 into 1 factorial plus 2 into 2 factorial plus up to k plus 1 into k plus 1 factorial is equal to, see, instead of n, I have to put k plus 1. So if I put here k plus 1, my entire thing will become k plus 2 whole factorial minus 1. This I have to put. I think you are following this lecture, okay, and it is making a sense. Is it making a sense? Does it make a sense? Yes. Okay. Alex. What is Alex's? I will copy this one. This one is Alex. We have to prove Alex is equal to RHS. So I can write this further as, okay, this is further equal to. How can I write this? I know that preceding term of this will be k into k factorial, because k plus 1's preceding is k and its succeeding is k plus 2. I can write in this manner. 1 into 1 factorial plus 2 into 2 factorial up to k plus 1 into k plus 1 factorial is equivalent with this. And what is this? This entire thing we know that from step 2. From step number 2, we can write instead of this k plus 1 factorial minus 1. I would say this, okay, this is separate. This one is separate, this one is separate. So for this term, I can write k plus 1 factorial minus 1 plus k plus 1 factorial. Here you have to write using step 2. Okay. Now how to write it further? This is further equal to. Okay, this is further equal to. Let me rearrange the terms for my own understanding. Okay, so what I'm doing? I'm saying k plus 1 multiplied by k plus 1 factorial. Okay, plus k plus 1 factorial minus 1. Only I have rearranged. I have taken this entire thing as a first k plus 1 into k plus 1 factorial, then this k plus 1 factorial, this k plus 1 factorial, and minus 1 total. Okay. I'm trying to arrange it in some manner so that I will get RHS, nothing else. Okay. So this is for the equal to. This is for the equal to. Let us try to take k plus 1 as common, k plus 1 factorial as common. Let's see what happens. So I'm taking k plus 1 factorial as a common. So what remains inside? If we take k plus 1 factorial as a common from these two, what remains inside? So for the first bracket, I am left with k plus 1, and for the second, I am left with only 1, and this minus 1 as well. You are clear? Okay. How this k plus 1 comes? We were having k plus 1 multiplied by k plus 1 factorial. I have taken k plus 1 factorial outside. So what is remaining inside? This k plus 1 for the first term. For the second term, we were having only k plus 1 factorial. As I have taken this as a common, I am having 1 inside. Okay. So this is for the equal to. You will have something to say. You will say that there should be bracket. No? Let us say there is a bracket. If sign is same, there is no need of brackets as well. Okay. So how can I write this? It is nothing other than k plus 1 factorial, and this one is k plus 2 minus 1 as it is. Okay. What is this? K plus 2 k plus 1 factorial multiplication. I am rearranging the terms. I can write k plus 1 factorial multiplied by k plus 2 or k plus 2 multiplied by k plus 1 factorial. It is one and the same thing, minus 1. This is further equal to. What is this? K plus 2 into k plus 1 factorial. It is nothing other than k plus 2 factorial. How come? What is 3 factorial? 3 factorial is 3 into 2 factorial. In the similar manner, k plus 2 factorial is equal to k plus 2 into k plus 1 factorial minus 1. This is equal to RHS. Alright. As we could see, LHS is equal to RHS. We would say that P of n is true for all values of n greater than or equal to 1. Whether it is making sense, whether this example is clear to you, should I repeat anything out of this? Okay, it is clear. All are saying clear. It is clear. Okay. So now, is there anyone who would like to share his solution for any of the examples discussed? Anyone who want to share something? Yes? Who want to share their solution? I will stop my sharing and you can continue with the sharing of any solution. Nobody. Okay. No? If no one is there, You can again take a snapshot and we will have a few more examples. Okay. So this was the solution that I have given you. Example number 11. Prove that sum of cubes of the consecutive integers is divisible by 9. This is the example. Next example. Okay. But it says we need to prove sum of three consecutive integers are divisible by 9 for all n greater than equal to 1. Let us see. Okay. Value of n greater than equal to 1. This is also here. Example number 12. You are having time till Sunday. So you have to solve all these and get back to me. I will not be discussing anything about this in the next lectures. Okay. So in case you are having doubts, get it clear in today's classroom. The next one is prove that 8 raised to n minus 3 raised to n is a multiple of 5 for all n greater than equal to 1. So example number 12. And one last example, example number 13. Do that 1 raised to 3 plus 2 raised to 3, 1 cube plus 2 cube plus up to. I am okay, quite confident that you are going to get some difficulty while solving example number 13. 13 is something different. Okay, 1 cube plus 2 cube up to n cube is equal to 1 plus 2 plus up to n whole square. Again, it is for all n greater than equal to 1. So take a snapshot of this and have a solving of the same. Have you taken the snapshot? Have you taken the snapshot of this? Snapshot is taken. Okay. If snapshot is taken, you can turn on your video cams and we can stop for today. Okay, you have taken already this. You can turn it on. Yes, you can turn on your video cam. Let me see all of you. Okay, Abhishek has turned on. How about others? Abhishek is saying Anuraj, then Viraj, this Sunny, Ruturaj. Okay, who else? Wonderful. Observing any girl. Girls, don't you have sufficient bandwidth? Okay, we will stop for today. Have a great day. Bye.